How's going on everyone? Welcome back to another video in data structure series. In our last two videos, we have learned how we can implement singly and doubly linked list in C and C++ using structures and classes. In this video, we will learn how we can implement circular linked list in C and C++. As we have already learned in the introductory video to linked list that circular linked lists are of two types, singly circular linked list and doubly circular linked list. Now, singly circular linked lists are quite similar to singly linked list. In singly linked list, each node points to the next node in the list, and in the next pointer of the tail node we store null. But when we talk about singly circular linked list, here also each node points to the next node in the list. But instead of storing null in the next pointer of the tail node, we store the address of the head node. This means that now we can directly jump from tail node to the head node. Similarly, we also have doubly circular linked list. These linked lists are also quite similar to doubly linked list. In doubly linked list, each node points to the next node as well as the previous node in the list. And we store null in the previous pointer of the head node and the next pointer of the tail node. But in doubly circular linked list, instead of storing null at these positions, we store the address of the tail node in the previous pointer of the head node, and we store the address of the head node in the next pointer of the tail node. This means that now we can directly jump from head node to the tail node and from tail node to the head node without the need to traverse the whole linked list. So now let us see how we can implement these linked lists in C and C++. First, let us understand how we can implement singly circular linked list in C. Now this program is very similar to the program which we have discussed for singly linked list. So we will only discuss the differences between these programs. For detailed explanation of this program, check out our video on singly linked list. Link is given in the description box. You can also press the I button. So the first difference is in the create list function. Earlier in the program for singly linked list, whenever we created a new node, we initialize the next pointer of that new node with the value null. But this time we are initializing it with the value of the head pointer. This means that we are storing the address of the head node in the next pointer of the new node, because this new node is going to be added at the last of the linked list, and the last node of the linked list has to point towards the head node of the linked list. When we add the first node or the head node in the linked list, we store the value of the head pointer in the next pointer of the new node. But as initially when there is no node in the linked list, the value of the head pointer is null. So null is assigned to the next pointer of the new node. Now when we add this new node in the linked list, we store the address of this new node in the head pointer. And after this we again execute this statement. This is because we want that the next pointer of the new node should point towards the head node, and earlier we had stored null in the next pointer of this new node. Now when we have to add other nodes in the linked list, we traverse to the last node of the linked list and add that node after it. To traverse through the linked list, we use a while loop. Earlier in the program for singly linked list, this while loop would terminate when the address stored in the next pointer of the current node was equals to null. If the address stored in the next pointer of current node was equals to null, then it would mean that we have reached a tail node. But this time, instead of null, we have stored the address of the head node in the next pointer of the tail node. So our while loop terminates when the next pointer of the current node is equals to head. This means that we have reached the tail node. And after reaching the tail node, we store the address of the new node in the next pointer of the current node. In this way, new node is added at the last position of a linked list. Now we can use this to add as many nodes as we want in the linked list. Once we have created our linked list, we want to print the linked list. And for that, we use a printlist function. Now in this printlist function, we again declare the current node pointer and initialize it with the address of the head node. Next, we traverse and print out our linked list using do while loop. Earlier, we were only using a while loop, and that while loop would terminate when current node was equals to null. But this time we are using a do while loop instead of just using a while loop, and this loop terminates when current node is equals to head. Now why are we using do while instead of using while? Now if we use only while with this condition, our loop will not run for even once. Because when this condition would be checked for the first time, this condition would return false as we have initialized the current node with the head pointer. So this condition would return false and our loop will not run. So instead of using while loop, we are using do while. Here, first we print out the data stored in the current node, that is the head node in this case, and then we assign the address of the next node back to the current node. In this way, we move one node forward in the linked list. And now current node is no more equals to head. So this condition returns true this time and the loop runs. Now when we reach the tail node, the data stored in the tail node is printed and the address of the next node is assigned back to the current node. In this case, the address of the next node is head. So head is assigned back to the current node. So this condition is checked once again and this time it returns false and our loop terminates here. In this way, we can print our singly linked list. Now let us run this program. Let's enter 6 elements. Here we get the elements which we have entered in the linked list. Now let us understand the program for doubly circular linked list. Again, this program is also very similar to the program which we have discussed for doubly linked list. So we will only discuss the key difference between these programs. And for detailed explanation of this program, check out our video on doubly linked list. Link is given in the description box. So the first difference is again in the createList function. Here also, we initialize the next pointer of the new node with the address of the head node. Next, when we add the first node or the head node in the linked list, again we store the address of the head node in the previous as well as the next pointer because it is the only node in the linked list and therefore the both pointers point to the same node. Next, when we have to add other nodes in the linked list, again we use a while loop and this while loop again terminates when the address stored in the next pointer of the current node is equals to head. This means that we have reached the tail node of the linked list. Once we have reached the tail node, we store the address of the new node in the next pointer of the tail node or the current node. After this, we store the address of the previous tail node in the previous pointer of the new node. Now our new node has been added at the last position of our linked list. And as the previous pointer of the head node should point to the tail node, therefore we update the value of the previous pointer of the head node and we store the address of the new node in the previous pointer of the head node. So now the previous pointer of the head node also points to the new tail node of the linked list. Once we have added the nodes in the linked list, we can print out the linked list. And to print out the linked list, we are using this printlist function. This printlist function is same as a printlist function which we have discussed just now for singly linked list. Here also we declare a current node pointer and we use this to traverse the linked list. And to traverse the linked list, we use this do while loop which runs until current node is equals to head. And each time we reach a node, we print out the data stored in that node and move to the next node. Next, we print our linked list in reverse. And for this, we created a backwards list function. Now here we have a major difference. Earlier in the program for doubly linked list, to print the linked list in reverse, we first used to traverse to the last node of the linked list to get the address of the tail node, and after that we used to traverse in reverse direction and printed out the data stored in the each node. But now we already have the address of the tail node stored in the previous pointer of the head node, so we need not to traverse the whole linked list to get the address of the tail node. So here we create a new pointer called tail. In this pointer, we store the address of the tail node which is stored in the previous pointer of the head node. And now we again create a new pointer called current node and this time we initialize it with the address of the tail node. Now once we have the address of the tail node, we traverse the whole linked list in reverse direction, again using this do while loop. And this do while loop terminates when current node is equals to tail. So first we print out the data stored in the node and then we assign the address of the previous node back to the current node. In this way, we move one node backwards in the linked list and we move till we reach the head node. So when we reach the head node, we print out the data stored in the head node and we assign the address stored in the previous pointer of the current node back to the current node. So here the address of the tail node is stored in the previous pointer. So now current node is equals to tail. Therefore, this condition returns false this time and our loop terminates. In this way, we can traverse the linked list in reverse direction. Now we can run this program also. Let's enter 10 elements this time. Here, we can see that our program prints out the linked list in forward as well as the reverse direction. We can also write these programs in C++ using classes. So instead of using structure, we would use a class and in this class, we would create public variables. And instead of using malloc to allocate memory, we will simply create a new node class. Rest of the program is same as the program which we have just discussed. The only difference would be in some syntax. Same goes for the program for doubly linked list in C++ using classes. Here also we use classes instead of structures, and in this class we create public variables. So that's all for this video. As always, you can find the source code to these programs on our GitHub profile. Link is given in the description box. In the next video, we will see how we can perform insertion and deletion operations on singly linked list. So thank you for watching this video and subscribing to our channel. If you found this video helpful, please give it a thumbs up and subscribe our channel for similar content. If you have any doubts or suggestions for us, feel free to share with us in the comment section. You can also contact us through our Instagram profile. Link is given in the description box.